question 18 says this. We have a system, but one of the coefficients here you see replaced with some parameter, or not one, a few coefficients here, replaced with the parameter lambda, lambda, and lambda in here. And you have to see whether, you have to analyze how many solutions the system will have. You don't have to find the solutions themselves, just how many of them, one, no, multiple, depending on this parameter lambda. I think you have on the top of the question 18, I think question 19 and 17 of the same nature actually. You have to decide how many solutions you have depending on the parameter. So having this theorem we discussed today, all we have to do, we have to extract the augmented matrix, that's the extraction. First row, second row, and the last one is the extraction. Oops, sorry. And we have to convert this to the row echelon form and see what will happen with pivots depending on the parameter lambda. Well, first step of the reduction is easy because we have very nice pivot here, pivot 1. It's always a good pivot to deal with because using this pivot we can easily vanish this number and we can vanish this number. These are the operations which are required. We will add a second one to the first one, and we will add, or we will subtract the first one scaled by lambda from the third one. If I do these operations, these two components will vanish. Something will happen here. It will require some writing. It's rather big matrix. Let's just do it carefully. So if I do that, look at this. The first row, it is the same. Second one, 0 as expected. Here we will have lambda plus 2 because we add them. Here we will have -1 plus lambda, and here we'll have 1. This is the result of this operation. The result of this operation, here it is, 0 here as expected. -4 take 2 lambda, that's true. Lambda take lambda square, that's true. And -1 take lambda. Well, the good news is that if you choose this as a pivot, this number, which now need to be vanished, this number is a -2 of this one. But computationally, it's a good news. You don't have to write a lot. So in fact, the operation which we need to achieve 0 in here is this operation. We have to double the second one and add to the third one. Relatively easy operation. No lambda involved. If I do that, here's the result of my reduction. First row remains the same. Second one remains the same. Last one, it will change. 0 here. 0 here is expected. This number, it will be the length is, it will be a rather lengthy expression because we have to multiply this by 2 and add here. The result of this is the polynomial like this, negative lambda square plus 3 lambda take 2. And there will be something on this side. That's the expression on the right hand side. This is a row echelon form, and now we can analyze this. How many solutions this could possibly have? My 3 pivots here, and my number in here. So if this one is 0 and this one is not, that's the case for no solutions. If this one is 0 and this one is 0, this is the case for multiple solutions. If this one is not 0, then that's the case for unique solution. This polynomial, you all know, it's a Vieta's theorem. Solutions to this polynomial are like this. And now I conclude that we have no solution if lambda is 2, because when lambda is 2, this will be 0, and this will not be 0. We will have multiple solutions if lambda is 1, because in that case, this entry and this entry will be 0. And we have unique solution if my lambda is neither 1 or 2, because in that case, this number will be non-zero, and this one will be also, well, actually, we don't care what that will be in that case. What do you think? will you accept that solution? Everything seems in order, right? We just took the matrix, we found the row echelon form, we analyzed how many pivots we have and where the pivots are, and here's the final answer. But I guess from the tone of voice of mine, you're suspecting something fishy here, right? Well, I lied to you when I said here, when I said we can use this pivot to vanish this one. That was an outright lie. It's not a pivot in general, because pivot's supposed to be non-zero. And the value lambda equal -2 will be a counterexample to my claim this is a pivot. So this solution will work. I mean, you can use this as a pivot as long as lambda is not equal to -2. So all of these conclusions we come up with here, they're all true as long as lambda is not -2. What's going to happen when lambda is -2? How are we going to fix my solution to address that problem? Thank you very much. You can do it. You just take this matrix. This stage is all right. No objections against this stage. You take this matrix. You sub in -2 as it is. You will come up with the matrix with pure numbers. Here it is. Here's my substitution. For lambda equal -2, that's how my matrix will look. And I do this separate analysis of this new matrix. It's like a branching out. We're branching out from this stage for the case -2 and finish row echelon reduction for this particular matrix. Well, for this particular matrix, we require this elementary operation. We have to multiply my second row. Now we're going to use this as a pivot, -3 as a pivot. If I multiply my row by -4 and add it to the third one, the result of this will be like so. You will vanish this -12, and you will end up with something here non-zero, which is, according to my theorem, means that for lambda equal -2, we don't have any solution. So -2 should go into this part of my answer, and -2 should be excluded from this part of my answer.